got one that should be fairly brief. I think it's not a super challenge, but it's fun nonetheless. And what I'm going to try to do is just construct the smallest natural number that meets this criterion. And the criterion is that each of the first 14 natural numbers must divide n, capital N here. Now, just to be sure about the notation here, an example would be 3 in this number theoretic vertical bar. 3 divides 12, since 12 divided by 3 is equal, or excuse me, since 12 is equal to 3 times 4. Okay. Another way of stating it equivalently. Okay. Okay, so that's what we mean by divides, and by this statement, 4 would also divide 12, right? So let's try to construct this thing, and the construction itself will assure the viewers that it's the smallest natural number that meets the criterion. Now we can certainly leave out 1 from this list, right? The natural numbers are 1, 2, 3, 4 ad infinitum. So we can leave out 1, but let's just write down that number n as we go. So certainly 2 divides 2, right? Now when we get to this next stage, we need 2. Should I put commas here? Yeah. We need 2 times 3. 2 times 3. So far we're doing good. 2 divides 2 and 3 both divide 2 times 3. Okay, now we get to 4. Now here all we need to do is add an additional copy of 2. So we can write this as 2 squared times 3. Right? You see we're adding just enough, and in this fashion we can see that 4 divides this number, but both 2 and 3 still divide this number here. And here's where just leaving the prime factorization is best. There's no need to try to evaluate this right now. Okay, now we need for our number n to be divisible by 5, so we just tack on 5 here. So we have 2 squared times 3 times 5. Now we catch a break, folks. Once we get to 6, we already have 6 is 2 times 3, so we can just skip 6, right? Because it already divides our little number up to this point. Right, so we'll skip, we'll omit or skip 6. And we certainly need 7, don't we? So we just have to concatenate 7 onto this number, and hope I don't run out of room here. So we'll have 2 squared times 3 times 5 times 7. Okay. Now, so folks, I knew I'd run out of room, but hopefully I can keep this straight. Let's just come down underneath here. Now for 8, all we need to do is increment this by 1 to make it 2 cubed. Everything else will remain unaltered, right? So let's come down underneath here, folks. Again, for 8, all we have to do is just increment this exponent and write down the value 2 cubed. 2 cubed times 3 times 5 times 7. Okay. Now, in a similar fashion, that was for 8. And for 9, now for 9, y'all let me, hopefully this isn't getting too out of hand here. So for 9, we just, everything's good except we need to make this 3 squared, so 9 will divide it, right? And so we will write down 2 cubed times 3 squared, and that accommodates 9, which is equal to 3 squared, right? Okay, and then we have times 5 times 7. Whoops. Times 5 times 7. So we're doing good, right? Making sure I'm not making any typos here. Yeah, we recopied this. We made this a 3 squared, and we recopied 5 times 7. Now, where are we at? That's to handle the 9. That's to handle 9. Let me point to this. Now, lucky for us, since we're running out of room, we can skip 10 because 10 already has a 2 and a 5 in it, right? So no need, we can skip 10. Okay, but we certainly can't skip 11. So y'all, I think I'm in good shape right here. I'll just try to rewrite this right underneath. My goal is just to carefully transcribe this with an 11 attached. Okay, so we're going to write down 2 cubed, 3 squared, times 5 times 7 times 11. Okay. Now for 12, I hope we catch a break on this. Now this would be 2 squared times 3, right? But we already have 2's and 3's all over the place, right? So again, we can skip 10. Now we can also skip 12 right here. We can skip 12. I'll just circle 12 as a skip, okay? So we got skip 12, all right? And then again, and the reason is you have a 2 squared times 3 sitting right here. So 12 easily divides our current state of affairs right here. Okay, now 13 is a prime number and not included. So we have to get that written down. And let me come down here. So you see, this is going to be, I'm just going to recopy this, 2 cubed times 3 squared. Okay, 2 cubed times 3 squared times 5. And looking ahead, it looks like this is probably going to be the answer. 5 times 7 times, what do we got? Times 11. And then we got to put the 13. I sure hope those dots are showing up, okay? So this is 2 cubed times 3 squared times 5 times 7 times 11 times 13. And guess what? This just worked out very nicely. 14 is 2 times 7, right? So we can skip that because there's already a 2 times 7 present in this prime factorization. So yippee, we're done with this thing. We got to skip these numbers, and I'm going to double check this before I upload the video. But we got to skip 1, 2, 3, 4 of the entries. And so this number right here, whatever it evaluates to, is the answer. And just by construction, it's necessarily the smallest number. Okay, hope you enjoyed it. And tell me what you think about that. We don't have to go through any kind of proof to prove it's the smallest one because it definitely meets that criterion just by the way we constructed the number.